Have you ever been on or seen a hot air balloon? I'm sure you've always wondered how a hot air balloon worked. Today we're going to learn how a hot air balloon works using the yard games. This will be our hot air balloon right here. It shows our temperature outside of the balloon and inside, the balloon's weight, the amount of volume it has, and the amount of fuel. Let's now see the particles of our balloon. Now, these are all air molecules. The air molecules are all the same temperature, which means they're all the same speed everywhere, which includes inside and outside of the balloon. If we heat the balloon, the air molecules inside of the balloon will speed up and hot air always rises. So the balloon will begin to go up soon. But as the molecules speed out, some of the air gets spit out, as you can see, making less air molecules inside of the balloon. This helps make the high speed molecules, and the less amount of molecules helps make a low pressure. Now, if we heat the balloon again, we've created the low pressure, and let's cut the rope. Now the balloon has traveled 100, 200, 300, and 500 might be its max. And now it's gonna go down. It's gonna be about 1,000 meters of movement. Its altitude is now going down quite a lot. And now we've traveled 1,059 meters. Now you might have noticed something. The balloon stopped in an area, and that's because of gravity. Gravity pushes everything down, you may know, but that includes the air molecules. Each of these molecules are being pressed down by gravity. Now, as gravity pushes down on this, the air molecules try and get underneath of the balloon. When they try and get underneath and we burn the balloon, it helps push the balloon upwards. Now, let's try again, and you may notice something about the arrows on the balloon. Did you notice it yet? The top arrow now is a lot larger than the gravity arrow. But now, look at this. It's now in the same place for a while, and both arrows are in the same spot, about the same length. This is called neutral buoyancy, in which the balloon stays in one spot, it's not moving at all, any higher or lower, like this. It's perfect. You could see the line, and when it's perfect like this is neutral buoyancy. But now, slowly, gravity is beginning to pull our balloon down. If we open the flap, our balloon will go down faster because it's letting go of more air molecules. Now, so far we've traveled 3,000 meters and our altitude is dropping from 600 meters to 500. Seems pretty good so far. I'm gonna reset our balloon. And now we're going to look at volume. Let me just turn on the particles and the arrows. And now let's see volume. Volume right here is here. Now the volume of the balloon is how large this is, you could see. Now the larger the volume, the more gravity's effect is a lot less. See, there's a lot more volume, and the gravity on this is a lot less than the gravity on a lot less volume. That's because gra- on more volume, there's more space for the air molecules to go inside of. There's a lot more empty space, meaning there's a lot less fuel that you could burn. See, just with a little bit of fuel, the air molecules already are ready to fly off. But now, let me, but now we're flying high. But if I do this, it falls down almost immediately. That's because there's a lot less space for molecules to get inside of, meaning it's a lot harder to burn. See, look at how long it takes for this to go up. It's taking quite a long time. I'm not even sure if that would work. So let's just bring up its size just a little. This is our balloon when we began. And you may see it's a lot longer than it took to this. Did you see how fast that went? Wow. And now if we bring it down again, it's gonna go a bit slower for us to see. Now, I hope you learned how a hot air balloon worked, and as always, stay curious.